So here, this problem, we need to show that the sum of the two vectors BE and TC that equals to 3 over 2 times the vector BC. And it's given here the D and E are the midpoints of the sides AB and AC of the triangle ABC. Okay, let's try to first sketch the figure. So we have a triangle with vertices A, B, and C. We have 2 points. Point D is going to be the midpoint of the side AB, and point E is going to be the midpoint of the side AC. Our goal will be to show that BE vector, that means the vector formed by joining BE going from B towards E added to the vector going from C to D, we need to show that their sum equals 3 over 2 times the vector BC. Okay, let us begin. So first what we'll do, we are going to consider the position vector of A, B, and C, but for the simplicity purpose, what we'll do, we'll consider A to be the origin. So here we'll consider the position vector of B to be B vector and the position vector of vertex C to be C vector. So now that we have defined the position vector of vertex B and C, we can define the position vector of the point D and E as well. So here we have point D which bisects AB, so that means it's dividing AB into ratio 1:1. So here we can apply the internal section formula. So OD vector that will be given by, now what we'll do, we'll take this one, that one will get multiplied to the position vector of vertex B, so that's B vector, added to, so this one will now get multiplied to the position vector of A. Now since A is the origin, so that's simply the vector 0, divided by 1 plus 1, so this corresponds to the vector B vector over 2. So that's going to be the position vector of the point D. Similarly, we can find out the position vector of E, so that's going to be simply the vector C divided by 2. Then let's now start by finding out B vector and then adding it with DC vector. So by definition, BE vector will be simply the position vector of point E minus the position vector of the vertex B, added to DC vector. So DC vector will be position vector of point C minus the position vector of the point D. So OE vector, that will be C vector divided by 2 minus OB vector, so that's going to be simply the vector B, added to OC vector. So OC vector will be C vector minus OD vector. OD vector will be B vector over 2. Fine. Now we have C vector added to C vector over 2. So that's going to give us 3 over 2 C vector. Then we have negative B vector minus negative B over 2. So that's also negative 3 over 2 B vector. So if we combine both of them by taking 3 over 2 as the common vector, so we have C vector minus B vector. Now what's C vector? C vector is nothing but OC vector, that's the position vector of point C, and B vector is the position vector of point B. So we have OC vector minus OB vector, that means we have BC vector. So we have successfully proved that the BE vector when added to DC vector, so the sum equals 3 over 2 the vector BC. So this is proved.